Hey there, and welcome to our second to last video in the Learn APL with Neural Networks series. In this video, I'll be talking about the outer product and the over operator. So if you know these two things, feel free to skip this video. Otherwise, just stick around. So what is the outer product? The outer product is an operator that takes a function and then takes a binary function, and two things and a left and right argument. And my explanation is terrible. Let me restart. So the outer product is an operator that will apply a function to every possible combination of left and right arguments that you give it. So for example, if you have a 2, a 3, a 4, and you have in here a times and a 1, 10, 100, say that if you press enter, this is what happens. But imagine that what you wanted was multiply the 2 by all of these numbers, and the 3 by all of these numbers, and the 4 by all of these numbers. Suppose that that's what you wanted to do. So you wanted to apply the times to every possible combination of left and right arguments. If you wanted to do that, then you'd use the outer product operator, and the outer product is just a jot dot. So this is what it looks like, and maybe this is weird for you. It's a little bit weird for me, but you just grow into it. It's kind of a monadic operator in the sense that it only takes a function, but then the jot and the dot are actually symbols of operators, so maybe it just looks weird, but trust me, you'll get used to it. So yeah, you can have any function f in here, and with the times, what I'm getting is I'm multiplying every number on the left with every number on the right. You can see here the first row, 2 times 1, 2 times 10, 2 times 100. The next row is 3 times 1, 3 times 10, 3 times 100. And the last row, the same thing. And what's important here to notice is that the numbers on the left define the rows, and the numbers on the right define the columns, okay? And sometimes the order in which the result appears is important. So just bear that in mind. And by the way, the outer product, you don't have to use vectors as arguments. Sorry, my brain froze for a moment there. This could be a 2x2 matrix with the numbers 1, 10, 100, and 1000, and the outer product would still work. Okay, notice again that the first axis here was determined by these numbers, and then the matrix goes into the other two axes. Okay, so this is the outer product in a nutshell. And the other thing we want to take a look at is the over operator. And the over operator is typed with APL shift O, and that's because APL O gives you the circle, and the over operator is the circle with the diaresis on top. So APL shift O. It looks like a surprised face, a surprised emoji. And what this over operator does is, well, it's a dyadic operator, so it expects two functions. And the function and the derived function, so this as a function can take either one or two arguments. So if it just takes one argument, then f over g applied to omega is just the same as f of g of omega, and that would be equivalent to also having f jot g. However, and this is what over is interesting for, if you have alpha and omega, so if you have a dyadic call to this derived function, what's happening is f is going to be applied over a pre-processing step done with g on both sides. So this, let me comment that so that I don't run this by mistake and get an error. So this is the same as doing g on alpha, doing g on omega, and then doing f on that. Okay, so this is what the over operator does. When is this relevant, or how? Well, let me give you an example of when this could be helpful. For example, say that you have a vector and another vector, and yeah, something like that. And you want to find out the length of the two vectors concatenated or catenated together. So what's the total length of the vectors? And well, you could obviously do tally of v catenated with v2. That certainly works, but you can do something else, which is you can find the tally of v and you can add that to the tally of v2, right? But now notice that you're in a way pre-processing the two vectors with the tally. So you first compute the tally of each vector and only then you add them. And that's the same as typing v now plus over tally v2. So it's the same thing. It's just an example. And in our code for the neural networks, what we will see is that this will be helpful because our network expects column vectors and returns column vectors, and our data is given as rows, and we will see that using a over table will help us turn our arguments into columns. So that's essentially what we will be using it for. So yeah, these were the outer product and the over operators in a nutshell. Feel free to play around with them and to just try to use them in your code and look at older code of yours and see if you can insert these operators there and if they can solve any problems for you. And then I'll see you in the next video. Bye.